Well, while we're waiting, hi Emil, thank you for showing up. We sure appreciate having you here. It's been a while since we've
Hello.
chatted. It's great to
Yeah,
see you.
long time, right?
Yeah, it's been way too long, way
Yeah,
too long. It's great to see you. It really
I've been
is.
out for some time, but well, I've still been in the open source business, but I've left the seed events business somewhat lately, unfortunately. So I'm more focusing now on supply chain security, and that's why I'm here mostly.
Well,
But I'm
we've
a
got,
former CD Foundation active participant at least.
well, this is we call it a micro conference. We've got some really good talks today. Actually, I've
Yeah,
seen them
cool.
all and they're all good.
Looking forward.
So yeah. But we're doing some interesting work in the space right now. So Emil, it'd be great for you to get back on some of our calls. We're looking at, and I'll talk about it, but yeah, there's some stuff that I think you'll be interested in what we're up to.
Hmm? Interesting, yeah. Yeah, I've been poking around a bit and seeing what happens, not least in OpenSSF, but also in some other areas.
Yeah.
And yeah,
Yeah, we still support the CD Foundation. Have
I
our
know.
hearts there.
Yeah, that's great.
All right, Steve, are we good going? Have we gone live?
Yep, everybody is good to go.
All right. Well, thank you everybody for attending our micro conference that is hosted by the Ortelius open source community. We started this conference because we saw a gap in conferences that were great for first-time presenters. That being said, I don't know if I think we might have one first-time presenter today, but it does provide a platform for getting your talks out there, getting them recorded, and getting them shown through the CD Foundation, the Linux Foundation. Because in the future, if you want to use those recorded conferences, you can do so to apply for things like KubeCon or DevOps World or any of these conferences. So that's how we got started. We always start with what we call beer and donuts, and beer and donuts is just a way for us to say, "Hey, you guys have all done great work," and go through our contributor awards, and then we jump into a series of conference presentations. And I'll kind of announce that after we've gone through our beer and donuts. So, welcome everybody. And as oftentimes Sasha says, Sasha Wharton, he says, Ortelius is the best open source community. And I would have to say, are a fun group. We have become friends over the years of developing this software. And it's been a pleasure to work with every single one of you. And you all feel like family, and we all aliens. We definitely are. So I am happy to, say that we have been around now for almost 5 years. We've delivered a MVP that's really needs to get adopted in the market now, and we've done some amazing work. So thank you, everyone. So I'm just going to go quickly through what we've accomplished over the course of the last 6 months. For those of you who are new, we do this every 6 months. We do SecureChainCon in May, and partly because we celebrate Abraham Ortelius, our namesake. And then in 6 months after that, we do our holiday party, which we also do presentations. And so in the meantime, in between, I just report on what we've done, and we award our badges to folks who deserve recognition for the hard work. So one of the things that this group, the outreach group, decided to do in early January was help contributors find new jobs. There was a recognition that the way jobs are found is very different today than they have been in the past. You don't just get a resume, really tight resume, and submit it. You have to deal with much more than that. You have to deal with AI bots. You have to deal with social networking, and it can be a lot. So we decided to create some job seeker webinars. We've done our first two. The first one is a super must. It is all about how to brand yourself in LinkedIn for recruiters. Darren Straff is amazing, and he is available to work with anybody who needs help in pulling together their LinkedIn profile, and he's also a recruiter. We Secondly, we did a follow-up of webinar to that brought in two amazing recruiters, one that works for a company to recruit and one that's a contract recruiter. And they described why LinkedIn is so important. So between the two, you get a really, really good view of how the new job seekers world works. We also created a blog, thanks to Tony Corrado and Jing Chen, that it gives us some resources. So you can go to the Ortelius website and go to our blogs, and you'll see the job seekers. We also created part of the CDF, but initiated by the work that we're doing in software supply chain. We created the CI/CD cybersecurity SIG, and we're building a CI/CD cybersecurity guide. It's not easy. This is a huge task actually, but we take one thing at one item at a time and we work on it. And what we're doing is we're looking at standards like the Secure Software Development Framework, which is where we started. We go through every single section and we look at every task that might be achieved through the CI/CD pipeline and how you would achieve it. By the end of the day, we've broken it up into 3 areas: code and pre-build, build and deploy, and then post-deployment. By the end of the day, you can look at your pipeline and you can try to assess what tools you might need to meet the Secure Software Development Framework. It is challenging to do, it really is, but we're learning a lot. And the fearless leader that we have is Kate Scarcella. She is our chairperson. Kate has an amazing background to work on this area, and we're super happy to have her. She also was mentioned in Meet Kate Scarcella. The CDF did a post on her. And by the way, everybody, yes, that is Kate wielding a fake knife. And what's called, I think, what is it called, Kate? The kind of martial art that it is?
It's martial blade concepts.
Martial blade concepts, yes. So yes, that's really her out there sparring with a fake knife, which I was pretty impressed by when I read her article. So what's next for outreach? We need to really focus on getting adoption for the Ortelius evidence store and vulnerability tracking. It's time. It's well baked. There's more testing that the community can do, and I'll talk about that in a minute. But we really need to work from an outreach perspective on reaching out to our Jenkins. Jenkins is a sister organization in the CD Foundation. So we really want to reach out to them, let them know what we're doing and how to integrate Ortelius into their pipelines so that they're starting to manage vulnerabilities post-deployment. That's the key. We're not trying to replace software composition analysis. What we're doing is saying, great, do that work, but then when there's a new vulnerability that is discovered post-deployment, we want to expose it, and we really would want to do auto remediation around it. The other amazing thing that happened this first 6 months is Sasha Wharton became part of the Continuous Delivery Foundation's governing board. So it's awesome to have one of our gold legends elected to the board. That means that he attends the management meetings as a committer representative. So he gets to be the voice of the committers for the CDF. This was an elected position. So, it shows that the Ortelius community is grown and is big enough to get one of their committers on the governing board. So congratulations, Sasha, and I hope you have fun with that effort. But our architecture accomplishments haven't been so great. We're running jobs on a regular basis, but we don't have the kind of pull requests that we should have. And it may be because the product has reached a level of maturity, but there's plenty of work to do around it. So I hope that we can talk about on the architecture side in the future here, how we can get more contributors back involved in building out the platform. And in one of those areas is we have begun an AI journey and working with model context protocols. And Emil, this will be interesting to you because this could be a different way to do CD events, to be quite honest. So Utkar Sharma, who is also one of our gold legends and has I believe he got a degree, and if Utkar, if you're here, and I'm saying this wrong, but he recently got a master's, I believe, from Oxford, specializing in AI. He is leading the charge to pull this architecture together. And what it will allow us to do potentially, and just initially what I want to happen is once we report on a new vulnerability, which we are already doing, we should at minimum for a critical or high-risk vulnerability that has shown up in a production artifact, at minimum right now, we should create an issue. And we want to do that through MCPs. So if this is something that you might be interested in, this is the time to get back involved in the architecture group. And maybe we can get some of those pull requests back up. And let's just go through the awards. So for those of you who don't know, we do badges every 6 months. The ambassador awards are awarded for those individuals who've been on our outreach committees. It focuses on outreach, adoption, and education. So I would have to say that both outreach and architecture has some big goals for the next, I'd say, 6 months. One, adoption through the Jenkins community, and two, building the AI piece and getting the pull request up. But this year for our individuals who are bronze recipients, we have those folks who submitted talks for this SecureChainCon. Abhishek, he's a co-founder of SafeDep. He's come to some of our architecture meetings. Daniel, who's the co-founder and CTO of Scribe Security, his talk is amazing. Yuri, she's going to talk today about chaos engineering, which everybody knows is one of my favorite topics around security. And Jude Wellington and Kate are going to do a talk on shifting left and up and down and everywhere security needs to go. And this year, in this 6-month cycle, Kate has won a Silver Ambassador Award. Thank you, Kate, for all the work you do. Your leadership in the cybersecurity group has been invaluable, and we hope that you are going to stick around and continue with that very ambitious project. And then Jing. She's like the drip, drip, drip person. She's just out there when there's something that we really need, she picks it up. And her work in the outreach has given her a gold ambassador badge. So thank you to everybody who works on the outreach committee, but in particular to Jing and Kate for reaching these levels. Now, champions is where we find our architects, our folks who are coding, working on pull request, finding issues, testing, opening up issues can get you these badges. But this time around, we have none this time. So we need to, this is an area we need to work on. And I do think it's because of the maturity level the product has reached, but we do have new features that we want to work on. And then legends. Unfortunately, we don't have any legends this time, but I just want to remind everybody that in the past year or so, we've had people kind of in a cadence. So Utkar became our first gold legend in December. Sasha followed him up in May, and then Arvin followed Sasha up in December. So we missed somebody this year. Somebody out there should have gotten a gold legend award, and I'm thinking that Jing is on the path to doing that. So let's hope that Jing shows up in 6 months with a gold legend badge. She needs to get to a gold a champion badge, and that's where the work needs to be done. So maybe there's opportunity for that. And yes, our namesake is Abraham Ortelius. On May 20th, he published the first World Atlas. And when I first created the Ortelius project, I looked at what we were doing, and we do a lot of mapping. We map open source packages to their deployed endpoints. We map components to applications. So we do a lot of dependency mapping and graphing. And Abraham Ortelius did something really interesting when he built the first World Atlas. He reached out to different cartographers and said, hey, why don't you give me your maps And I'm going to look at the most common the most common maps, and I'm going to create what we believe to be the World Atlas. And that's how the first World Atlas was created by an open source community in 15. I think it was. I think we did it in 1570. So thank you, Abraham Ortelius, for showing how to do how it's done. And that is it. So what we're going to do now is we're going to bump into our keynote. Let me just go through quickly what we have on the docket. Sorry, somehow I bounced out of this. Okay. John Willis will be our keynote. And John Willis is known, if you've been in DevOps for any time, you know his name. He has been a thought leader in this space for many, many years. And now he is becoming kind of a thought leader in AI around DevOps, which is why I was excited that he agreed to do our keynote. So the keynote is an interview. So I'll be interviewing John, and we'll be talking about how we can use this new technology to build out better DevOps platforms. And maybe there'll be a day where we don't have a workflow engine like a Jenkins. I'd hate to say that, but it's very possible that there'll be a different way to do this in the future. That will be followed up by Jude and Kate talking about shifting security left, up and down, and across the organization. And they're going to do it by talking about how to bake a strawberry shortcake, which is really fun. And then Abhishek's going to really talk about something we all talk about on a regular basis, this hidden in the code, malicious code scanning for open source packages. SafeDep has an open source tool for doing this work. They're taking a new approach, and he's going to talk about that. And then Yuri's going to talk about, again, one of my favorite topics, which is chaos engineering. And she's going to actually talk about something we don't necessarily talk about all the time, payments and ransom gangs, and how chaos engineering can help solve some of these problems. If we get into the habit of always just responding as quickly as possible to cyber attacks, I think we're doing our job. And then Daniel from Scribe Security, he's really going to give us a talk on SBOMs. It wouldn't be SecureChainCon if we didn't talk about SBOMs. So on that, I'm going to leave the next about 8 minutes open for the group to chat, ask questions, and then we'll kick off the first presentation, which will be the keynote. So does anybody have any questions about what I covered, or how our badges work, or how you can get some, oh, sorry about that. How you can earn a badge, or just want to talk about what beer you might be drinking or what donut you might be eating. Or introduce yourself. Ben, why don't you introduce yourself?
Sure, I'm happy to. I apologize for being a little bit late. I'm in Mountain Time in the US, so it's a little bit early for me. Um, I run the engineering team and stack for Recon InfoSec. We provide managed security operations to critical infrastructure, manufacturing, governments, that sort of thing. We are using an almost entirely cloud-based stack. From our EDR to our email protection and everything, they're platforms. So my team and our job is to integrate everything. And we do that through a lot of CI/CD work goes into putting all that together. Most of our platforms, our primary ones at least, are all configured with infrastructure as code. So we have very detailed pipelines for maintaining all of that and maintaining customer customizations for various customers and things like that. I'm not or have not been a big part of this community. I'm interested to learn more about what you're doing and how you're doing it, and so that's kind of what brought me in. Someone referred it to me from one of our local infosec groups here in New Mexico. So,
Well, we're in New Mexico too, so
oh, okay.
yeah, we're just outside of Santa Fe. Ben, do you do any work with Platform One?
I do not right now.
That's the DoD's version of a CI/CD pipeline, and I'm very interested in learning more about Platform One. And they have another one called Space Camp, and I believe it's all built on GitLab, potentially.
Oh, okay.
Well, I would love to, let's definitely try. I'm gonna send you my email. So it would be great to chat with you, or maybe grab a coffee or a donut or a beer
Absolutely. I'm
in
I'm down
person.
in the west side of Albuquerque, sort of the
No
northwest.
problem. I'm there often.
Yeah, no, I would welcome the opportunity for sure.
Anybody else might want to introduce themselves? We did have a really interesting on the topic of job seekers. Uh, a woman by the name, I think her name was Rathana. She came to me via a woman that I've worked with for a couple of years doing some mentoring around getting uh, more recognition and branding. And she had a friend who was looking for a job and referred her to the Ortelius job seekers webinars. And she'd been looking for 6 months. She updated her LinkedIn profile, and within 6 weeks, she had her dream job. So we have done so, it doesn't matter how many people succeed. It just matters whether we do one. There's kind of a Buddhist story about a Buddhist monk walking along the beach, throwing back the starfish into the water. And somebody says, "Why are you bothering? There's hundreds." And he said, "Well, it mattered to that one." And that's sort of how I see things. If we helped one person, we did amazing, amazing work. So kudos to the outreach team for building those. And Tony Corrado, he's not here today, but he was super instrumental in the idea and getting it pulled together. Andreas, you want to, or Jason, you want to introduce yourself?
Sure, I could go next. Can you hear me?
Yes.
So yeah, I work more on the software security side. I'm with object security, and we focus on like automated binary analysis for finding zero-day vulnerabilities. We did a lot of our work with the DoD, so I'm pretty familiar with Platform One. We have some of our tools on there on Platform One and Two, so I'd be happy to talk about that sometime. And always interested in talking AI security and binary analysis.
That's amazing. So yeah, again, I would ask you to, in order to join the architecture calls or get the information, all you really need to do is join the Google group. Let me put it in the chat. And I would love to talk to you about Platform One.
There's a few other, they have like a few ongoing marketplaces that are kind of similar to Platform One. Um, there's like a whole group of them that the Air Force runs.
Well, there is the Google group in the chat. And Jason and Ben, I have sent you a private message with my email. Okay, and on that, it is 2 minutes to 9, so we should jump into our first keynote. I think you're going to enjoy this. There's a lot of geeky stuff talked about in this one because John can really go down into the AI in a deep way, but I think all of you will enjoy it.
So we're going to stream them live now. We will post each one individually out onto the Ortelius YouTube site. So if you need to run in the middle of this, you'll be able to come back to them. Let me get the sharing going. And we'll kick this off. Oh, maybe. It's thinking about it. All right, here we go. Thanks, everybody. Can you guys all hear the music in the background?
Hello, everybody, and welcome to SecureChainCon 2025. I have the pleasure today to introduce our keynote speaker, John Willis, or as we lovingly call him, the professor on some of the Techstrong gang calls that we do together. Today, we are going to be covering AI-powered code parsing and semantic analysis for DevOps pipelines. I know many of you have been hearing me kind of hammer on about where is AI in DevOps. Well, we're going to talk about that today with the professor. John, thank you for being here. And why don't you just get started by telling us a little bit about yourself?
Yeah, I guess professor with a lowercase p, if you don't mind, right? Yeah, no, been doing this an awfully long time, like yourself. I've gone through sort of like 4 decades of IT technology shifts, but probably more importantly is I'm well known for being one of the initial instigators for DevOps. I was the only American at first DevOps days. I helped bring the first DevOps days in the US. Co-wrote the DevOps Handbook with Gene, Kim, Jez Humboldt, Patrick Boy, and it just really became part of the DevOps thing. I've always been an infrastructure and operations person. And then about 3 years ago, I got really interested in, really actually scared. I'll say this real quick. I always think of infrastructure and operations people as cicadas. We go to sleep for like a number of years and then we wake up and like, what in the heck did you all do? And then we just literally have to start cleaning everything up, and we're in one of those cloud was clearly one of those moments. We're in one of those moments with AI, and I saw this, pretty early, looking at it from like, how are large corporations going to deal? They're going to do it. There's no stopping it. We've seen this with cloud. So therefore, how CIOs, what can I do to help a CIO try to see the future? And by the way, it's shadow IT all over again. So those kind of things I've been really focused. So 3 years ago, I really tried to understand, what is AI? How can I be intelligent about it? And how can I talk to an executive about what I think you need to prepare for?
Yeah, boy, I think I try to be as visionary as possible as well in these areas because, we have to navigate that, in particular through our open source project, Ortelius. So let me tell you what the Ortelius team has been working on. We have sort of a sub-architecture group led by a brilliant technologist by the name of Utkar Sharma. Right around the time I started hearing about MCPs, or Model Context Protocols, I got pretty excited because I started understanding the possibility that maybe we have, instead of LLMs and these foundational models, that we have small models, right? We have SLMs that could be more specific to a particular domain. And I didn't know about it, but that the Utkarsh and Steve Taylor had been talking about MCPs as well. So I brought it up to the team like it was a new idea, and they were like, yeah, we've been talking about it. So we started a little sub project, and they've done quite a bit of work around these model context protocols. And what we're looking at potentially doing, and I'm phrasing this so you could maybe give us a little bit of tips in this area.
Sure.
What we're going to do now, right now, is what we want to do is the project already can track a open source package to an endpoint running in a live environment. Think about military applications, right? Satellites.
Yeah.
We don't have to, and we do it through the DevOps data because we grab the SBOM, we grab the metadata from the deployment log, we version it, and then and we know, okay, this is running in production. We constantly synchronize it against OSV dev. So what we're looking at doing to start, just a baby step, is to use MCPs to do something very simple. We're going to first just create an issue when a critical or high risk vulnerability shows up, and create an issue for every single project that's using that, which is a lot, right? But what we want to get to is we want to be able to grow that to a full-on pull request by going through the process of finding a mitigation. And it may just be for the Docker files and the POM files. Correct the pin, right? The pinning of the corrected version, and create a pull request. So we're starting to think about how we can auto remediate for critical and high risk vulnerabilities that are actually impacting production. I realize all the other stuff is still important, SCA, trying to find it before you get it to production, but it's never going to end the problem of new vulnerability showing up after we've done all the shift left work. So we're shifting right a bit and trying to fix the problem from there, and we're growing into an auto remediation, so the tool's acting like a self-healing immune system. So in that kind of discussion, tell us, think about what it looks like for at least these large language models like CodeBert and changing kind of the DevOps game to do that kind of updating and automated self remediation.
I would start with the question, why do you need me? It sounds like you guys got it pretty well nutted right now in terms of, I mean, that just sounds fantastic, you know? So, I mean, it so aligns with all my research and understanding of like how we're going to emerge these problems. I think there's one thing I want to say, and then I want to step back a little bit. I think what's interesting about you'd mentioned sort of the excitement around small language models. I think what I'm finding is this hybridity between large language models for general information and then pinpoint the sort of the exact or the more locale information from smaller, it's basically expert models based on a topic, right? And then you throw a little bit of RAG in there. Now you got, and then you're spot on. The sort of agentic RAG or sort of the RAG architecture between I want to get general information. And again, as we all know, the reasoning models for the large language models are amazing. So you're sort of bouncing between, sort of frontier models and small language models that are very specific. You're collecting RAG information that gives you more context. So I think that's all good. I will, I know you're not a naysayer, but the step all the way back, I heard a presentation recently from LabCorp, and one of the sort of the chief AI officer, which I hate the idea that organizations are creating chief AI. Well, not so much that they're chief AI, the fact that they're separated from CIO is just that's no longer a discussion. But we gave a great presentation about how they built this remediation system for their 24-hour desk that answers calls from nurses and doctors on lab results. Right? It's highly technical, very sort of like high consequence enters, right? And so they went through the whole thing. They built the models. They did tons of work, and then they got challenged at sort of the first implementation about, oh, that's going to be dangerous. What if it gives out the wrong answers? Fortunately for this person, they had collected the last 3 or 4 years of all the transcripts. When they ran they ran a parallel evaluations, sort of the sort of computational and qualitative and quantitative analysis of answers, ground truth, and all that good stuff. And they ran that against both, and the remediation, the AI generated remediation was like 10% better than the last 3 or 4 years. So I think we need to start there. That this assumption that humans are by default better, I don't think that's the truth. To dive a little deeper. Yeah, I think I think that whole thing about where how we're going to be able to use it's awesome that you're excited about MCP, right? And it is this idea that we can now sort of glue things together with better intent. And what I mean by that was like I think RPA was a disaster. I know not everybody agrees with me. I mean, when I first saw it, I said this is going to be a train wreck. You're putting in systems that screen scrape a whole enterprise and make rule-based decisions. Now they said they used AI, but AI was like not in the reasoning models that we have now. And literally, and it did solve problems. Like it did, but it was just technical debt tsunami. And so what I think, I think the glass being half full of agentic protocols is that we're going to be significantly better with these reasoning models, particularly if we can use, like we said, large language models for general, small language models for specific, RAGs to help tell us more information about what has been happening in an environment and put all that together is going to be, I would say, if there's a benchmark eventually for this type of stuff, RPA would be in the 30s to 40%, and as these sort of agentic processes or these protocols it's going to be probably in the 70, 80s, maybe 90% from a
So let's
benchmark.
back up a minute, just because I know some of our viewers are DevOps people, and AI is not something that they're studying a lot.
Sure.
Let's talk about RAG. Can you explain this idea of this, retrieval
Yeah.
augmented generation and how it might apply to DevOps?
Yeah, no, it's a great. I'm glad you did ask that because sometimes I make a mistake assuming everybody knows the.
Okay.
I do that all the time. So RAG very simply is a way to augment a context window. So when you're dealing with, like, you go into ChatGPT, you say, who is Abraham Lincoln, right? Bang, bang, bang. But when you ask for, like, what is the bank policy for turning off all the roles and access for an employee, right? Like, you ask open any of those ones, it'll probably come back and say, well, I think, and based on a bank, it should, but like, it's not going to be your rules, right? And so, but you want that reasoning model power, right? That's the thing. These OpenAI and Anthropic and I'm a big fan of Google right now. So you want that reasoning power, but you want to put context sensitive. So what I'll do then is I'll put in this case, maybe I'll put all my HR policies that I have, try to scrape them, try to clean it up, and put it in what they call a vector database. And so that vector database now is a like, people who are AI people will punch me in the face for saying, but it's a mini sort of LLM, and it's not an LLM, but it has the same structure. So now you can query against that. So now you can ask the question against what do I do when an employee gets terminated here at Bank XYZ? And now it'll come back, it'll look for paragraphs, they call them chunks, that are in all this data. Now, again, that can be wrong too, right? Some of it could be, depending on how the data got in there, it might be an FAQ, it might be actually an SLP. But anyway, and then what you get back is you tell it, like, give me 10 paragraphs or 10 chunks based on this question. And then you can sort of you can use tools to check how accurate it was. And so maybe I take the first 3, and it is all sorts of what they call, re-ranking. But anyway, I'm getting too deep. But then I take all that, and then I put that in the context window of the large language model and ask the same question. So now it's got all this context that's sort of the first area of data before it gets into the model and uses the power of that reasoning model. And then you can get highly effective answers, low hallucination rates, by using that combination. So again, when we talk about DevOps, so here's a good example. If I sort of there's some tools now out there that are doing this, but you can do this yourself. If I start keeping track, like what you're doing, like you're keeping track of what's going on, what the pipelines, what's failing, what's not failing, what's all these things, right? And now I can put that in this vector database. So now what I can do, so here's a great example. So now, once I've got the RAG set up, I might use, I'm a big fan of Gemini 2.5 right now. So I might use but I could use any OpenAI ones. So now I can ask a question about, something, like tell me what is the most failed, sort of deployment, or explain to me why this one might have failed, or whatever, right? So what will happen now, it'll go to the RAG first, it'll pull out the most relevant context from that vector. I'll throw that into the large language model, say, hey, can you give me a procedure to do this? Now it'll look through the just thousands and millions. I mean, the large language models know a lot about DevOps. They know a lot about code. And then here's where your small language model comes in. So now I can get this sort of blueprint of a little bit of knowledge or a fair amount of knowledge of what was going on prior in this environment from the RAG. Now I'm getting a sort of a less than generalized answer, but has a lot of DevOps and has the context of what I get. But now I can say, and this is what you would do is all through an agentic process like an MCP. Now go ahead and start hitting the large language, or maybe it was something in in one of our SaaS providers. Maybe it was one of the things in, in a Jenkins file, whatever, right? Now I get these small language models that have very specific knowledge of what to do. So now you can start
So
seeing
now we can start thinking about predictive things, right? Being able to look at what happened in the past to predict what could happen in the future. I
and
think about the data all the time. I think about the DevOps data and how
yeah.
underutilized the DevOps data is. I mean, if you think about a company like CloudBeast, they should be all over Deploy Hub and Ortelius because they execute, I don't know, literally to support the Jenkins community, I don't know, 50, 70 million workflows a month, right? And that is a massive amount of very specific DevOps data that could be potentially leveraged to improve the CI/CD pipelines overall. Where is the congestion? Where are the problems? How do we know something that we're about to deploy is going to fail? Because maybe we already know based on Terraform scripts that these parameters are going to break before you even send it out.
Yeah.
So I feel like we're, in general, the industry's missing an opportunity and we really need to shift.
Yeah, and I think one of the things I think is going to be interesting, I said this to a friend of mine was at PagerDuty, and they were trying to get very early into incident management, and I said, that's like all the early examples to use Gen AI and incident, like, yeah, let me use my left hand and I'll code it while you're explaining it to me. It's that simple to do this stuff. But where I think the real power is for what y'all can do is be that resource. So you save me a step, be the resource that allows me to aggregate all that information in an intelligent way. Now you become a provider to me in a agentic process. So instead of trying to go out and sort of boil the ocean of I'm going to be the new DevOps and all this, like you're spot on, right? I mean, 2 years ago, IDC did a report and they said that 90% of the data, this is just general data, not just DevOps, but this would definitely apply to DevOps. 90% of the data in enterprise organizations is unstructured data, and often 50% is used only once. There's a gold mine. And what the beauty of Gen AI, and again, it's a predictive model. Yes, it can hallucinate. Yes, it can have wrong answers. But the beauty of Gen AI is to go after that 90% and turn it from pure data into knowledge. I mean, that's the gap. Like that all of a sudden now I've taken a ton of, so if we think about the DevOps space, what are all the things we can take just pure data and move it in an evolutionary step to knowledge? And now I can work against that knowledge, like you just said. Hey, based on what we know about this type of deployment and under these conditions and all this, can you give me a prediction? One other thing I don't want to forget too is this will get very geeky, but I think it's important. I think not only are we going to have large language models, small language models, I think we really have to embrace something Google talked about 2 years ago, a year ago. It's this idea of the symbolic neural networks, I think that's called. And it's based on Daniel Kahneman's Thinking Fast and Slow and Thinking One, Thinking Two. So the idea is that you're going to basically not just exclusively use neural network or predictive or what we call transformer architectures. There are problems that are going to make sense to be sort of old school AI, what they call sort of symbolic reasoning, which is and then I want to mix the symbolic and neural net or sub-symbolic, which is neural network, as a combination because there'll be probably, especially in DevOps. In DevOps, there are things that we want to be reasonably deterministic, right? There are certain problems. This whole thing, if you Google it, it's called alpha geometry, I think it's called, right? And they realized to solve they were trying to go after like, what is the top geometry students? What's their rate of passing tests? And they found you couldn't use just a neural network to solve the problem, because you needed the symbols. You needed to combine the combination of sort of rule-based with probabilistic or neural networks, right? And I think as I was sort of doing a little research for this conversation, I thought, I think that is going to be an important thing because there are things I think we'll know. You ask some questions about like, do we do semantic analysis and things? There's going to be answers where yes. And I think and again, I have not done this, but I think that's going to be a fascinating area to explore.
So another area that I think that we're missing out on, and I don't know if AI could solve this, is software debloating. I mean, the amount of open source packages that are probably consumed and
Yeah.
not used is probably close to 50%. How is is there some potential in being able to pull in dependencies and start debloating software?
Yeah, I mean, again, I think the important point is goes back to that LabCore example. That's why I wanted to make it. The answer is yes. Will it be, in that answer, the executives are right. Like, it may give an answer that will harm a human, for the LabCore example. But we were already 10% worse,
Right.
right?
Well, we always said software, if you can get 80%, you're doing really well.
Yeah,
Right?
and I think the benchmarks on a lot of this stuff is like hitting 70, 80% right now. So I think the answer is AI and generative AI will literally make it will surpass human and rule-based technologies to do this, unquestionably. Will it 100% right? No. Um, but I do think that as we start thinking about like how do we start thinking about these tools? I mean, the beauty of these tools is they can understand at an incredibly efficient speed intent and execution logic. Right? No real human could figure that out. And I think that's the missing when you go back to all the sort of tools we've been using for dependency mapping, all that. They couldn't understand language, the combination of like understanding like the NLP, the language, the intent, and the sort of execution flow as a combined. So it is better than humans right now. It will continue to be better than humans, but it will never be perfect. But I think like that's an area where that needs to be explored deeper
Well,
and
there's
deeper.
just some things that humans can't. The dependency graphs of the open source world is impossible. It's absolutely impossible for a human to do it. We have to create some automation. We
That's
have
right.
to create some intelligence around it in order to start reducing that dependency graph, so we can reduce the attack surface. Right? We have a massive attack surface that we have to do something about, and I feel like if we can collect these dependencies, and this all comes from SBOM, so we have a good amount of that information.
That's right.
If we can start gathering this information and we can start applying it. And your topic on neural nets, that was one of the things that I thought about when I started learning about these APIs, these MCPs.
Uh-huh.
Because this now, we have an amazing opportunity to be able to go out and share data across these smaller language models and almost create a neural net, right? Isn't that what we're doing in essence?
Yeah. We're training, we can train models, exactly.
We
In
can
fact,
train models, and we can be more specific about training models if they're more domain specific and not foundational. I
That's
feel
right.
like having the foundational models actually downgrades the quality of the data.
Yeah, but again, go back to perspective. There's multiple ways to sort of solve this problem, right? One, sort of an agentic RAG is one, right? In other words,
Right.
I can use the power of that. So what I can do is sort of take a lot of the data, and then you've got graph RAG and all that stuff, right, too. So I can actually build these sort of RAG-like implementations to have more knowledge, so then I can let the foundation models do the deep reasoning, right? And that is. But I think the thing that you have to figure out is how far do you get on the sort of meter of what you want to accomplish. And if you find that like doing the RAG and there's things like re-ranking, and you can do a lot of cool stuff with RAG implementations, to get it pretty far without having to bring in somebody who knows how to sort of actually, run PyTorch or TensorFlow, right? But
Right.
there's a point at which then, okay, the question then is, and this is for anything, not just sort of dependency understanding, is, what is the consequence of a wrong answer? Is it good enough to be, ragged and agentic RAG and all that stuff and re-ranked? is the answers that you're going to get. And you can calibrate the answers to something called evaluations. Um, and then, or LLM as a judge is one technique. But then is that sort of range good enough? And it might be, yes, for this, it is good enough. If it is not, then the next step is you really do have to start training your own model. And that's a whole nother step of understanding, I would say a couple of years ago, there were very few people. There's a lot of students coming out of university now that like
Well,
literally,
that's what I was going to say. In the Ortelius community, we have made it a focus to say, let's do projects that allow people to educate themselves, get some experience on a real project that they can put on their resume. So that may be our next step because we want part of this process. We went through a whole phase of learning blockchain, right? And creating immutable records for blockchain, primarily for the purpose of education.
right.
And if it builds something cool inside the product, great. If it doesn't, that's okay too. People have gotten a lot of background. So before we run out of time, I want to follow back up with my point in the beginning in terms of what the team is looking at doing. So tell us that we're on the right track, or if we're not, in terms of doing that auto remediation step in the process. So what we would do is if we would find, let's say, heaven forbid, we have another log4j issue. And we have a new version of log4j, we need to add the new version into the POM files or the Docker files. What we want to be able to do is go through an organization's entire GitHub, all the repos that they're managing, find every single script that uses that and update it. Now, I know we can do that. I mean, I can think about ways to do it without AI, but
Right.
I think that there is a model to be pursued that doesn't just update that one pinning, but maybe corrects that it looks for problems and cleans up those Terraform scripts, those Docker files that have maybe some problems in them. Are we close in creating that autoimmune system?
Well, I don't know if you remember when we first met, and it was just sort of like bump into each other, and we didn't really have a great conversation. But it was one of the swamp ups. And I
Yes,
and I remember you seeing like, and I know who you were, and then I said, "Oh boy, let me look at it," right? And I thought, okay, there's a lot of stuff going on here, and maybe nobody really understands what you're really trying to do. Like I
I
got
think
it
they.
pretty quick, but I was like, you had to have some deeper understanding to know what the value could be exposed here. I think the world has caught up to you. I think now, what I'm hearing and I'm seeing is all the things that you've been sort of doing for quite a few years. That knowledge, and this is the beauty of the sort of AI. What I get really excited about is like for me for research. If I know what to ask, I can do incredible research. I think for y'all, you're seeing that all this stuff that you've been, I wonder if I could do this. I'll say one, I know we're going to run out of time, but I go in these companies and do these hackathons. And I try to start not with a technical, let's write a bunch of stuff. I try to invite the business leaders to do like what we call a no code or concept hackathon. And then all of a sudden you see supply chain and forecasts and finance groups you sort of give them the overview that like we're not creating any flying cars. We're like it's not magic. There are some ground rules of what AI can and can't do. But you watch them think about the problems they've been trying to solve for years. And now for the first time, they see the capability of possibly solving those problems. And what I'm seeing, so the answer is yes, you're spot on. And it's going to be an evolution. It's going to be, it's not going to be easy. There's a lot of stuff going on here, but I think that like that goes back to the unstructured data thing. Just get the data into these
Get the
systems.
data. That's what and the DevOps data is so left out in the cold.
It is.
It baffles me every day to think about all those workflows. We're executing millions of workflows a day and nobody's collecting or managing
But
that data. It's just
key point
completely
though is
unstructured.
if you don't know, and this goes back to your expertise. I've gotten to know you through the Tech Gang Exchange and your expertise and knowledge in this space, and it's very deep. And so the beauty is, you get the data and your sort of understanding of how these things work for working in years. That's where the magic starts happening. And I think this is, you know, again, this is where it gets really exciting about like subject matter expertise, getting access. You've always had access to the data, but the way you had to get data was through scripts and sort of like
Most
just
people, we have the data, but it's checked into Git in
right.
an
And it's
individual script sitting there doing, that's like what's an SBOM. An SBOM's useless unless you
that's right.
consume the
That's
data and do
exactly right.
something with
That's
it.
right. And actually, I have an article coming out this week about AI SBOM. So that's going to be a whole nother.
I just started learning about AI SBOMs and I was
That's
looking at what they create and I'm wondering how useful it could be for what we're doing. But I think there is some interest in there, especially the version of the LLM.
the version of LM,
Yeah.
the license, the whether it's using an open weight model or. But here's another thing that like another area that I've been more focused on is what is the new pipeline? What is the software secure pipeline for creating these things? So as companies, this is there's one thing for all the things we're doing to develop software. That's not going. In fact, it's gonna like it's gonna get a lot more, right? Like more
Yeah.
code being generated. But at the same token, as we're building these sort of systems, our own sort of either RAG based or our own models, I'm thinking a lot about what is the sort of pipeline going to look like. And that has to be secure. Because the question that, like the new sort of audit question, the internal audit mostly, but probably external audit, is well, today, pre AI, it's sort of give me the provenance of this change. Right. And then you have to go back and sort of, well, we did this, here was the commit, all that stuff. You work, or did you do a SAS, DAST, all that stuff, right? The new internal audit question is, how did I get this answer? And that you're going to have, you can't just say, oh, well, Gen AI created it. No, sorry, I know enough about the tools to say that's not a correct answer. So you're going to have to keep your sort of egress, ingress, or ingress, egress to the LLMs. That's going to be mandatory. It's going to be a lot of data, but it's going to be mandatory. And you're going to have to show that. You're going to have to show that you have guardrails on the ingress and egress. Did you really try to protect somebody getting data that they shouldn't have got? Did you check the output answer? And then one of my main focus today is evaluations. These are tools that literally can create ground truth and test the accuracy of answers. Tons of work going on. It's been going on for years. It was part of the ML. Like now they call it observability for AI, right? And then going back to like, if you built a RAG, what was the code that you created those paragraphs, those chunks? And then all the way back to the data. So two things are going to happen is you're going to need DevOps automated governance, the attestations to say, I did this, I did this, I did this. Same proof that you do for any classic software delivery. And then the SBOMs are going to become incredibly important because not just the model, because I looked at some of the spec, the thing that's already missing is embeddings. A big
Yeah.
part of that chain is when you, especially in RAG, but anything, is using an embedding. And tampering with embedding can be one of the most vulnerable points in your pipeline in new AI stuff. So I want my embedding in Artifactory. I want an attestation that tells me that this answer came from that embedding, not just a model. And I want that in SBOM. So all the things, the data set, the license, if they were fiddling with the weights, I want the algorithm in some form. I don't know what it's going to look like. I want the model. I want the embedding. I want everything that I can create a bill of material for in an SBOM. So I think there's a tremendous opportunity in this AI SBOM.
And there's a big opportunity in gathering that data and making it actionable.
Oh, yeah, well, there you go.
Because that's the last step, right? It's great to have
Absolutely.
it, but if you don't collect it and track it and make it actionable, then
That's
we
right.
wasted our time.
Right.
Well, this has not been a waste of time. John, thank you so, so very much for taking the time to be our professor
Yeah.
for SecureChainCon
So,
2025.
and,
And welcome to being an alien. We say aliens are
there
real.
you go.
And
Okay, good, good.
you will officially get a badge for doing
I'm a
this from the
frog and an
alien
alien.
community.
So those are the two vendors that at least have annoyed me. And I will say, Tracy, it is always honestly a blast having conversations with you. And I mean that sincerely. Ever since we started on the Tech Strong gang and and these kind of conversations, because you're so knowledgeable and depth in an area that I'm more of a generalist on, and I just love having these conversations.
Well, thank you. Thank you for saying that. I so appreciate it. And we are have a full day ahead, or at least a half a day ahead. So stay tuned for the next person in the lineup for our SecureChainCon 2025. Thank you, John.
You're welcome. Thank you.
Okay, so I told you all that it was going to be a good lesson on from John Willis. I hope you all enjoyed that. I know I enjoyed interviewing him, and we have a few minutes if anybody wants to chat about what we just learned or add to that discussion. What does anybody, let's just open it up for, can we build a DevOps small language model? A domain-specific small language model? And can we do software? Can we solve the software bloat problem with AI? Anybody have any particular strong opinions on that?
I joined a little late, but like whatever he was telling, so everything seems like very um, something that is that should be there for DevOps tooling, and more of like whatever he is doing will evaluate pipelines at each steps, and there is something that we call explainability feature in AI. So if we can, build the same thing for a pipeline, it will be able to, give more information like how things are being moving in the similar analogy to how John was telling for ingress and ingress, right?
Yes. And so, Emil, now you know why I said this is it will be an interesting topic because we potentially, we've worked together on CD events for quite some time.
Yeah.
And maybe this is really where we should be taking it.
Yeah, it's an interesting side path, or what should I say? It could be a side path, or it could be actually the path. We don't know yet, for sure. So it's all about dealing with the data in the right way. And of course, I would be surprised if it doesn't help the LLMs that the data is also structured in some way, of course. So having them sending the data in a well-structured format doesn't hurt the LLM, at least. But at the same time, the LLMs can of course make sense of data that is not yet structured as well. So we'll see where it goes.
Absolutely. And
Well-
AI SBOMs is interesting too. I had just read about them when he brought that up.
That was totally new concept for me, but I'll continue looking for that.
The interesting part, I think, is going to be a lot of the pipeline data, especially the log output, disappears. It's not around forever, so you don't have a lot of the raw history as part of that process. Now, some tools like Jenkins and stuff like that can keep the pipeline logs, but a lot of people just go out and prune them, which could affect how we got stuff going on. It looks like we have somebody that raised their hand.
Yes, Rashna.
Yeah, I really like the talk around SBOMs and AI SBOMs. And in our lab, we are working towards experimenting with SBOMs, and it's still pretty new. There are many tools, but every tools are producing results in different ways, and many of them are not compliant with NTIA's, the minimum requirement stuff. So there is a lot, and I really love the idea of getting the data and making it actionable so that we have somewhat at least one or two source of tools which can generate useful SBOMs. And I feel it can help debloating as well in later period. If the SBOMs are perfect, it can definitely help debloating software.
Yeah, I think debloating will be a conversation we'll be having more often in the near future.
I think one of the other things that will what we're working on right now, we're working on just the vulnerability management and being able to auto remediate the vulnerabilities. I mean, the bigger task would be to go and actually fix developer scripts. I mean, like the Jenkins, all the groovy code that runs Jenkins that the developers have created, or their Jenkins file, that type of thing, or go and correct your GitHub action to make it more secure. I think that is a good next step to really help clean things up, and then also being able to tell AI go and update all my repositories and add a SBOM to my pipeline.
Bingo, bingo. That's really where we need to be. That would be really amazing.
And that would be involving, going and figuring out for this repo, are they running Jenkins? Are they running GitLab? Are they running GitHub Actions? And from there, how do we go and update and insert into the right place the SBOM generation? Because the one thing I've know from all my years of working in the DevOps world is no one developer or DevOps person creates the same solution in the same way. It's all very Wild West, put it that way.
And Ben posted a comment, a way to solve I think the data gathering to make it consumable for AI would be to pour the logs into OpenSearch. Ben, you want to expand on that or say anything about that?
Sure. The comment was made that a lot of the logs from pipelines are just kind of getting lost or pruned away, boiled away into space because nobody's consuming that data. OpenSearch actually works as a really good source you can vectorize in front of OpenSearch. It scales really well for all its faults. So pouring those logs into OpenSearch would give you a way where they were easily consumable for your AI model to use as a reference and a source of data.
And what's the cost associated with doing something like that?
The storage.
So you just have to figure out a good storage mechanism that's cheap.
Right. Yeah. It's OpenSearch is open source and free and easy to relatively speaking, easy to maintain. The biggest cost is really just the amount of horsepower and storage it takes to run.
Yeah.
Interesting. Thank you for that.
Well, we'll get Sasha to create. Sasha loves his Raspberry Pis and his Kubernetes cluster, so he'll probably stand up a bunch of Raspberry Pis with a couple terabyte disk drives and call that the OpenSearch solution.
He's our master platform engineer. And Utkarsh, when I was speaking to John, I talked about you, and he may start attending the architecture meetings because he was pretty excited about what we were up to. And I shared some of the graphs that you're working on after the call. So we might find John Willis on one of our future architecture calls because he's pretty excited about what we're working on.
That would be nice. That would be nice.
Okay, next up is Jude and Kate, and they're going to teach us how to make strawberry shortcake, as well as talk about how security's got to be shifted left, but that's not the only place it needs to be shifted.
Hey, everyone. Thank you so much for joining us today. So why the strawberry shortcake recipe? As Kate and I were talking about this topic, she shared this very meaningful strawberry shortcake recipe. And so we started thinking about how cybersecurity should be bite-sized and consumable by everyone. And yes, Kate and I followed the recipe and made our strawberry shortcakes. It was my first time ever baking, so thank you, Kate, for empowering me, getting me out of my comfort zone, and doing something different and meaningful. So why the cybersecurity comparison to dessert? Because both depend on strong foundations, careful layers, and end-to-end thinking.
Exactly.
So here we go. My name is Jude Wellington. I run ITMP LLC. We are a startup. I'm also the CDF and CICD West Coast Meetup organizer. And as a founder, I'm wearing every hat in the company, and cybersecurity has to become a priority. And joining me on this talk is Kate Scarcella. So Kate, please introduce yourself.
Yes, so I'm a cybersecurity architect with over 20 years of experience. I have a Master's of Science in Information Security from Nova Southeastern University and a certified information security system professional. So let's do this.
Yeah, let's do this. So, Kate, today our engagement is going to look a little different. And we're going to talk about building a cybersecurity culture, one that's foundational, repeatable, and actually consumable for everyone involved.
We're going to do this, what you might not expect, through the lens of baking a strawberry shortcake.
Right. It's a dessert that's been around for decades, right? So sure, there's many variations, maybe fancier plating, a twist on the cream or cake, but at the end of the day, the core ingredients haven't changed.
That will be the main theme throughout this presentation, because just like these ingredients that don't change, it's the same, believe it or not, for cybersecurity. While we've piled on new tools, flashy frameworks, and trendy buzzwords, but the foundation of resilient security comes down to a few consistent ingredients: people, process, and mindset.
Absolutely. And so our goal today is to not just talk about shifting left, we want to shift the conversation entirely to show why a secure culture is a real strategy and how it can be inclusive, sustainable, and even, dare we say it, consumable.
So let's bake this in from the beginning, right? Let's make
Yep,
cybersecurity something everyone can be a part of and proud of.
absolutely. So, Kate, how in the world did this happen? Cybersecurity has been a complicated mess, and it's like we've dumped this burden of national infrastructure onto everyday folks like me and say, hey, good luck. They're trying to juggle compliance and patching and endpoint protection and software vulnerabilities, all while we're, trying to run our business. Frankly, it's a burden we're just not meant to carry. And in many cases, we simply can't. As a small business owner, Kate, where do I begin?
So first, your pain that you feel, just so you know, it's not just with you. It's across organizations everywhere, truly. It's like, and what we're doing is we're asking small business owners to suddenly become a part-time security analyst.
Yeah.
And the way that we have responded, it's like watching 5-year-olds play soccer.
I remember that's such a visual. I remember seeing our kids, chasing around this ball in these groups and no positions or no strategy.
And while it's endearing, right, to watch everyone run watching the 5-year-olds run after, the little ball, but watching everyone run after the latest threat, something happens, boom, SQL Slammer hits, and we react, and then we scramble to build products after the fact. It's the cybersecurity version of whack-a-mole, totally reactive. I will never forget SQL Slammer when that hit. And our response to that, we beefed up antivirus tools, developed malware analysis platforms, rolled out intrusion detection and improved intrusion prevention systems. But all that was after the fact. It's like installing locks after a break-in.
Exactly. You know, we started building a whole security industry on these reactive tools. I was just at RSA, and yes, while they're valuable, they're only part of the puzzle. You know, it feels like we've lost the plot here. We've built these massive castles with lots of tools, but not systems of resilience. And, you know, that's where this analogy shifts for me. Maybe what we need isn't just better locks, it's better nutrition, right?
Yeah.
Like food groups. Think about it. We've got different categories that keep a system healthy.
It's a cool thought, nutrition and cybersecurity and food groups. What I can personally say is that security architecture isn't just one giant product.
Hmm.
It's a balanced meal. So your network security, those are your grains. That's foundational. Your application security, your fruits and veggies, full of nuance and complexity. Database security, maybe the protein, high value and deeply sensitive. Identity and access management, dairy, because wow, they're huge. And let's just say that's what keeps the bones of the system strong. Security analytics and incident response, that's the oil and the fats. You don't need it in excess, but it's vital when something burns.
Oh man, I love that. So instead of, you know, piling on random tools, we think like nutritionists. So we ask, is your environment getting the right balance of ingredients, right?
Yes, and it's no more chasing the soccer ball. It's time to pick positions, design the playbook, and build the team with the right training and diet. It's time for cybersecurity to really grow up. Think about strategy over reaction, architecture over chaos. No more, throwing spaghetti on a wall and looking at what sticks. And
Yeah.
no more whack-a-mole, right?
Right, right. And maybe, just maybe, we stop expecting regular folks like me to carry the weight of bad system design. So, so we've gotten our ingredients, right? Network application, database, identity, analytics, but just having those ingredients on the counter doesn't necessarily make a strawberry shortcake, right? You need a recipe. So, Kate, how do we put this together in a way that actually works?
Well, we start by the strategy. That's the first thing. Think of the directions in a recipe, order, timing, methods. Cybersecurity has had to grow up and start thinking this way too. One of the earliest recipes was the CIA triad: confidentiality, integrity, and availability. So, late 90s, this is when this um, framework came out, and it still shows up everywhere, especially in critical infrastructure because of the legacy hardware systems.
So it's like flour or sugar and eggs of security, right? You can't bake anything without those three concepts.
Right. But then as things got more chaotic, cyber attacks became more advanced and faster. We had to change how we think.
Yeah.
That's when we saw left of boom come.
Mhm.
In borrowed from military lingo, it asked, can we do something before the bomb goes off, before the virus spreads?
Right. So instead of just cleaning up after the cake collapses, you know, we should be checking the oven temperature. We should be prepping the pans. We anticipate what could go wrong.
Then that's right where the strategies like proactive threat intelligence,
Mm,
system hardening, security engineering come in. You
yeah.
want to catch the issue, before the first line of code is ever written or before that 0-day is exploited.
Right. And so that leads to another modern approach, this shift left approach. We realize that waiting until the cake is in the oven to ask, hey, did anyone check for allergens is a little late, right?
That's exactly it. Shift left means baking security into the process from the start. You don't sprinkle security on top at the end. You mix it in early, during design, during development.
Right. So, if I'm thinking about this in the kitchen, left of boom is prepping your kitchen, checking your ingredients, sanitizing your tools, preheating the oven. Shift left is planning the recipe itself better, writing it in a way that avoids failure from the start.
And the CIA triad, right? That's the reason
Mm,
we're making the shortcake in the first place. We wanted it to be protected. That's our confidentiality, untampered. That's integrity and ready to serve when needed, availability. So we don't get rid of these foundational concepts.
I'm giggling because cybersecurity as a shortcake, I mean, who knew, right?
Yeah, right. Just like baking. And if you skip a step or throw in ingredients in the wrong order, you might still end up with something, but you probably won't want to eat it.
So true. Oh, um, so Kate, here's the question here, okay? In the current emphasis in cybersecurity now, mostly on securing coding, I mean, with all the shift left talk, have we just shoved all of this burden onto developers?
You're not wrong. We absolutely have. Developers have absolutely been handed a lot, but we need to zoom out. Secure coding is foundational, yes, but real security is not just in the code. It's in the culture, it's in the people, the process, the technology, the full mix.
Yeah, absolutely. Because the truth is, most breaches, they don't just start with one line of code, I would think. They start with a human decision, right?
Yes, and this traditional shift left says fix it in development. But true resilience means shifting mindsets, not just milestones.
That's what we need to bake in, Kate. Security isn't a checklist, it is a mindset.
And we go back to our strawberry shortcake analogy. We've
Hmm.
been dumping all these different security strategies and ingredients into the bowl. Some of them work beautifully, but others don't mix well at all.
Yeah, like trying to take a bite of a shortcake that's all sugar. Oh man. Or worse, even all salt.
Yeah.
No.
Yeah. It's not just about one ingredient, it's about the right
Yeah,
combination, proportion, and mixing.
that's right. So what are these fresh ingredients, Kate, of a strong cybersecurity culture?
First, if you, the obvious, if you need multiple, and you will need multiple ingredients. You want a great dessert, you use fresh fruit, real whipped cream, not shortcuts.
That's right. And that applies to teams too. Security can't live in just the SOC. It includes everyone from the summer intern to the execs, even to the contractors, right?
Right. And from a person who's like been in SOCs forever, security operations centers, I can tell you it's good for us to get out. You bake security into the onboarding, communications, office culture. It's posters that say security starts with you. It's making everyone a part of this recipe, not just icing on the top.
Yeah. So, uh, maybe the most important underrated ingredient of all is respecting that every role adds flavor, meaning security isn't just technical, it's organizational. And when we mix it right, that's when we get something truly sweet.
What an awesome idea.
Yeah. All right. So Kate, what are some of these areas you've seen where there are real gaps in cybersecurity culture? And of course, how do we translate this? Maybe back to baking.
Yeah, the first thing that comes to my mind, always like high up there on this list, is misaligned incentives.
Mm,
Speed over security. That happens a lot. It's like trying to
hmm.
bake a cake faster by turning the oven up to 500 degrees. You're just
Right.
going to burn the outside and ruin the inside.
Yeah. Like cut corners. You can't just get you will get undercooked a center or a charred crust. It's not exactly secure. Am I right?
Yeah, absolutely. And then there's risk decisions made without security input. That's like second on this list because that's baking without a recipe. That's throwing in what you think belongs, hoping for the best. It might look okay for a minute, but it won't hold up under pressure.
And what about the people we forget, like the contractors or the non-technical, staff? That's like realizing you don't have fresh strawberries, and so you stop the whole bake?
No,
No.
no, exactly. You adapt, right? You bake with what you have. Maybe it's frozen berries this time.
Yeah,
And security, that means including everyone. Even if they're not in the core kitchen, give them what they need to contribute safely. Even
right.
if they're only here part-time.
Yeah, yeah. Oh, here's another one. No psychological safety. If people are afraid to
Mm,
speak up about mistakes or suspicious behavior, that's a recipe for disaster. Like it happened to me. I was a victim of a cybersecurity scam, and I did not know what questions to ask, and I was afraid to even raise my hand up to
mm.
get the help that I really should have needed.
And you're not alone. Today, the cyber threats are very, very real, and they're fooling even the best of the cyber security professionals that are out there.
Yeah.
So, in terms of, bringing this back to baking, what's worse than a group bake when there's no one is that no one says, hey, the oven's not on. Then you pull the cake out and it's raw. We need to build in processes that
Yeah.
makes it safe to raise concerns. No shame, no blame. And one of the things that I talk a lot about with cybersecurity, we often think that, oh, this is fun, threat hunting and things like this. But a lot of cybersecurity has to do with process and procedures, making people read the text, you see what's
Yes.
there.
Absolutely. Yeah.
So working from home, that has brought in
Mm-hmm.
challenges as well, especially for cybersecurity professionals. But
Right.
sometimes the ingredients are harder to access. No direct line to IT, no hallway conversations. But again, it's about adapting the recipe, not abandoning it.
Yeah. Because really, you can't fix cultural bugs with technical patches, right? You can't solve a broken cake with more frosting, can you?
No, you fix a cake by improving the batter, the oven, the technique, and
Yeah.
sometimes the team.
Yeah. Right. So So we've touched on, end-to-end thinking a few times, but let's break it down. What does that really look like in cybersecurity?
It means no one gets to say, that's not my job when it comes to
Hmm.
security. It's not just
Yeah.
about the dev team or IT or compliance. It's about everyone, from the first idea to the final delivery and everything in between.
Yeah, yeah, exactly. Everyone needs to get involved. I've always used this example, if a stranger walks into your house, what do you hand them the keys and say, hey, help yourself to the fridge or the files or the family photos? Of course not.
And I just love that example. It's a perfect example. And of course, no way would you do that, right? That's exactly what happens though, when we don't think end to end. No access controls, no boundary,
Yeah.
just assuming someone else thought of it.
And if we, go back to our strawberry shortcake strategy, end-to-end thinking is about layers. It's not just about the frosting, it's the shortcake, it's the berries, it's the whipped cream, all of it layered right.
So I really like how you talked about a strawberry shortcake strategy. That should be the name of the next cybersecurity strategy. It's called Strawberry Shortcake Strategy. So cultural layers matter. We need security baked in across roles, not just in developers' hands. And I'll say this shift left push, it's
Yeah.
incomplete. Putting all that weight on developers, it's like handing the baker rotten berries and expecting a gourmet dessert. It's like good luck, right?
Especially, when the stakes are rising so fast, right? Exploits are going up exponentially. Look at what happened last summer, right? A top tier cybersecurity vendor's own sensors got exploited. Over what, 8.5 million systems impacted, the biggest outage in IT history, cross-industry chaos, billions in damage.
Yeah, and I'm sure it wasn't just me who had some personal impact. It's not that it was a failure of it. Well, it wasn't just a failure of technology. It was this failure in end-to-end awareness, process, and shared responsibility.
Right. Because, great security isn't just built,
Yeah.
it has to be sustained. And it's a living, layered cake, so to speak. And if one layer collapses, the whole thing could fall apart, right?
So we need to keep it simple.
Yeah.
Layer the culture like we layer the cake. Start early, include everyone, and
Yeah.
never assume someone else already did the hard part.
Right. Right. So here we are, Kate. We talked about shifting left, but I think we've been thinking too narrowly here, right? It's not just about shifting left anymore. It's shifting up, it's shifting down, it's shifting across.
And that's where the real transformation happens. You're exactly
Yeah,
right. Because not every organization has the luxury of a dedicated cybersecurity team, like
right.
right? Many small and mid-sized businesses don't even have a CISO, let alone a security program office.
Right. Yeah, I'm the see everything. And the shift left strategy just doesn't scale the same way for them.
Yeah.
They need a security model that works for everyone in every corner of the business, small corners up to the large corners, correct?
Yeah. So let's break it down.
Yeah.
Up is about leadership. Executives have to champion security as a business priority. They set the tone, they allocate the time, budget, and expectations.
Yes. And down
Yeah.
is all about teams and individuals. It's about embedding security into daily habits. Think locking our screens, right? Verifying strange emails, reporting suspicious behavior. It's everyone's job.
And you bring up a really good point. Locking screens. We can all do that.
Yeah.
That's a culture. That's a cybersecurity culture. Verifying strange emails. That's something we can all do. So when we think about now going across, because cybersecurity doesn't just stop at IT, it
Yeah.
hits HR, legal, marketing, sales. They all have skin in the game. What are the onboarding practices?
Mhm.
How are you handling customer data?
Yeah.
Everyone has to be embedded into these security decisions.
Right, right. This is especially critical for small to medium businesses like me. You know, they can't afford silos or these 90-page policies that no one really reads, right? They really need security that's practical, that's visible, and baked into how we work every day.
Yeah, think of baking like sharing a kitchen. It
Yeah,
doesn't matter if you're making cupcakes or a wedding cake. You're all going to be using the same space, same
yep,
fridge, same tools. So everyone has to clean up, label the ingredients, and protect what's in the oven.
Right. And that's how you make cybersecurity work, regardless of the company size. It's not just left, but up, down, and across.
And look, when everyone contributes, look at the beautiful cake.
Voila. And that is the
Oh,
cake that I ended up
beautiful.
making thanks to Kate's recipe. I really was just so honored to have been able to make this cake. So Kate, after all the baking and layering and shifting, what's our call to action? What do we want people to do with all of this information?
It's simple. Get involved. We need
Yeah.
you. We need you. If you felt burdened, if you're tired of this fragmented strategies, or you just want to be part of building something better, come join us.
Absolutely. Yes. So we're inviting you to be a part of this cybersecurity special interest group under the CD Foundation. This isn't just another committee. It is a place where real world practitioners, developers, architects, and business leaders come together to ask, how do we do this differently?
And I'll just like to end bringing in my silly little pan that I have here, because once you have the foundational ingredients or the
Yeah.
foundational concepts, you can then use different pans and do different things,
Right.
but we just need those foundational principles down and in this recipe.
Yes, yes. And, we're baking a new recipe here,
Yeah,
right? So
yeah.
something that's practical, something that's inclusive, something that's resilient, right?
Yeah, it's been around for, hey, strawberry shortcake has been around for decades.
Yeah.
And it's a phenomenal dessert, and we can make cybersecurity phenomenal. We all can make cybersecurity phenomenal.
Absolutely. So please join the conversation, help shape the strategy, and let's make security something we all own and something that finally works. Call to action, please join us.
Thank you.
Thank you very much. Enjoy the rest of the conference, everyone. Bye.
Bye.
Okay, I want to really know, Jude, did you bake that strawberry shortcake that you showed in the last slide?
I sure did.
You did? I am impressed. It looked
Yeah.
delicious.
Not only did I bake it, but I had to have my family try it, and my wife is like, I can't believe you're actually in the kitchen doing this. I'm worried, but it turned out so good, and
It looked beautiful.
it
It looked
really
totally beautiful.
thank you so much. And thank you, Kate, so much for the opportunity to have this talk in such a different way. It really is inspiring. And this kind of talk is something that I can share outside of, this technical community. I think everybody needs to understand how important cybersecurity needs to be within everyone's business processes, small, medium, large. Yeah.
So for any of you interested in joining what Kate's been working on, sorry, Kate, I put it in the chat. And just let me really quick here show you. I'm going to share my screen and show you. Oh, somebody else is doing it. That's okay. Yeah, sorry, I can't take the screen over right now. But go visit that site, and you'll see what we're working on at the Cybersecurity SIG. It has been a process that I have learned so much from, because when we go through it and we try to build our strawberry shortcake underneath the secure software development framework, you look through all those tasks and it is hard to determine if there is a tool or a practice that you can add to the CI/CD pipeline that will solve the problem. So it is not bite size. That information is really hard to follow sometimes. So that's what we're doing at the CI/CD Cybersecurity SIG. And it is a special interest group. The goal is to get it done and not have to have regular meetings to get it written. So if you're interested in helping with writing it and going through the task in the Secure Software Development Framework, that would be great. The next step is to use some of the OpenSSF information and map the Secure Software Development Framework task to the SIST, the CISA framework, so that we have one guide that says, okay, if you're trying to meet the CISA framework, here are some of the tasks that you can use to meet those requirements. So we have a long way to go, but we're working diligently first on the Secure Software Development Framework. And Kate, were you going to say something?
It's sort of unrelated to that, but basically, I just wanted to, hats off to Jude, because what I sent him and where he went with it was really, and I love from a cybersecurity perspective, working with people who aren't necessarily cybersecurity experts, because I love the way that the thoughts come about. And I think with the SIG and seeing how this is being written, it has helped me look at it from a developer standpoint, which technically I have not, and so this has been great for me. So thank you.
Me as well. I've learned so much. And Anne-Marie Fred, who did one of the first pages, did a rock star job. She has so much knowledge in this, and she is on the team. So if you want to learn from an expert, Anne-Marie's there. Okay, our next talk. Let me look at where we are. Let me quickly go to our next talk will be Abhishek from SafeDep. We're going to talk about hidden in the code, malicious code scanning for open source packages.
Hey everyone, thank you so much for having me here. Thanks to SecureChainCon for letting me speak as part of this conference. Quickly to introduce myself, my name is Abhishek Datta. I'm the creator and maintainer of VET, a free and open source tool in software supply chain security space. I am also the founder of SafeDep, which is a company working in the same domain. I had been a security researcher during the early part of my career, but kind of moved more on the software engineering and tooling side of things. I'll set the agenda for this talk. So at a high level, this talk is divided into 3 parts. I'll start by setting or establishing the problem of inherited risks from open sources. If you are a consumer of open source software, which is everyone, including us, then what are the risks that you should be aware of, particularly the problem of malicious code from open sources? Then I'm going to talk about what we do as part of our open source projects in terms of establishing trust on open source code at scale. So what we are building at SafeDep in terms of identifying malicious code from open source packages, I'm going to talk about in technical details with the goal of sharing, the challenges, what worked for us, what did not work for us, and how can the community leverage this. Finally, I'm going to talk about some of our open source projects like VET, like how the community can leverage VET in order to protect against malicious packages, or how our research can be leveraged. What are the next things? What are the challenges to be aware of in this particular domain? Before that, I want to start with a question. Do you use open source code in your application? This is a trick question, really. Everyone does, including us. We also heavily depend on open source code. What if I tell you unvetted use of open source code can get you hacked? And maybe many of you are already aware of the various incidents that have happened in the recent past because of malicious or compromised open source code. Let's start with a very obvious example of how we consume open source packages. Say npm install express. If you're from the Node.js world, you would immediately be familiar with this particular framework and the command, right? Here we are installing a very popular web application development framework package in the Node.js ecosystem called Express. This means you are going to add the code from the Express package and ship it as part of your application. So do you trust Express? I mean, if you ask me, I would say yes, I trust Express because it has all the signals associated with it for trusting. Like it is very well maintained. There are multiple maintainers. It is backed by a very large and matured community. There are regular releases and everything basically that would allow you to trust a project. But in reality, when you are installing an open source package, it's not just that particular package. It is actually bringing in a lot of other open source packages as part of its transitive dependencies. So when you're doing npm install express, it's way beyond just installing a single package that you trust. It's actually installing a lot of other code from the open sources in terms of dependencies for npm. Now, if you are a software development organization, you might be having a lot of secure coding practices, code review practices, and all of that in order to ensure quality and security of the final application that your team is delivering. Now, when it comes to first-party code, you would definitely review it. What about all this code which is coming from open sources? Did you code review them? Probably not. Neither do we do code review of every single open source package that we can use. What if any one of these packages are compromised or malicious in nature? You would most probably end up deploying malicious code in your production environment or end up shipping an application artifact to your downstream users or customers which has malicious code. That's a problem. So from a software consumer's perspective, there are two key problems when it comes to inheriting code from open sources. It can be vulnerable, in which case it is actually bringing in vulnerabilities in your application. You would typically do software composition analysis to identify known vulnerabilities in third-party libraries or packages that you are using in your application to protect against vulnerable open source. But the other key problem which we are seeing at a tremendous rate today is the malicious code from open sources. Think about it. Malicious code is different from vulnerability. Vulnerability is a mistake, a bug in code because of which has a security impact. It does not have any intention to harm anyone, right? But on the other hand, malicious code is created with the intention of compromising downstream users of open source, which is why malicious open source today is probably a larger problem when it comes to open source consumers. We would start with a real life example. So this is a real malicious package which we found a couple of days back. We reported it to npm. We got this particular package removed from npm, as well as reported it to OSV. So if you search in OSV, you would see that this package is reported as malicious, and we are referenced as the finder for this particular issue. So what is this? The name of the package is Express Cookie Parser, which was impersonating the very popular cookie parser library for the Express.js framework. The original cookie parser library has more than 3 million weekly downloads. So you can imagine how popular the package is. Now, this malicious package had the exact same README as the cookie parser library. In fact, it had the exact same API compatibility for the cookie parser as well. So imagine you're a developer, you're building on Express.js framework. Now you need the cookie parser middleware. You would probably search in npm.js or Google about Express cookie parser. So what are the odds of you finding this Express cookie parser library and using it, assuming that it is the original one? I don't think every time developers would manually verify downloads and all of that, right? if you would have used this particular malicious package, it would have worked exactly the same way as you would expect the cookie parser middleware to work, except that it had one particular malicious package or malicious code in form of this cookie loader.min.js. So this particular cookie loader.min.js was also loaded as part of loading the Express cookie parser middleware. Just that it would do a bunch of things before allowing you access, or before allowing you to use the standard APIs from the cookie parser package. So what it does, it first generates IP address of an attacker. So this was one interesting issue or interesting technique that we found. In most of the malicious packages, we found hard-coded IP address or hard-coded domain names with which it would communicate. Likely the attacker controlled command and control servers. But in this particular case, what we found was a domain generation algorithm. It would generate IP address based on some seed data and a hard-coded key. And from that IP address, this payload would download another JavaScript file called startup.js, execute it on the infected system, then remove this particular line, this require cookie loader.min from index.js, so that anyone who has who was compromised does not see any specific TTP of compromise or indicator of compromise, right? So pretty smart about that. So this is the high-level overview of this particular malicious package. But if you are interested in the full technical details of what does the malicious package do, what does the malicious code does, how does the domain generation algorithm looks like, please you can read that as part of our blog on this particular malicious package analysis. Okay, so we saw a real-life malicious package. Now let's talk about what we do in SafeTape in order to detect such malicious package with technical details. So our stated goal at SafeTape is really to protect software development teams against malicious code from open sources. So in order to do this, what we do is really continuously monitor supported open source package ecosystems such as NPM, PyPy, and RubyGems, and few more are coming for newly published packages. And whenever we detect a newly published package, what we do is we perform analysis at our end. If we detect any malicious behavior, we sometimes do static analysis, sometimes do manual analysis of the detected behavior, although given the scale of or the number of packages that we scan every day and the suspicious things that we find, it's not possible for us to manually verify everything, but we do look at suspicious flags or suspicious signals for popular packages. So what we do is that we either manually verify them, then get it reported to appropriate package registries such as NPM or PyPy, try to get it removed from the package registries so that people are not impacted, and then also include it as part of the OSV database so that any other tool can also know about this malicious packages. So this is what we are doing as part of our malicious packet scanning infrastructure at SafeTape. We do have a community feed. If you go to this vetpkg.dev/mal, you will see a continuous feed of packages that we are analyzing. This is almost near real time compared to what we see. So every time a new package is published on NPM, a job is queued at our end. Once we complete the analysis, it will show up here. So if you're interested in malicious package research or in general, how does some of the malicious package signals or evidences and behavior looks like, you can probably have a look. The thing to note is that these results are 100% auto-generated. They are not manually verified, so there are chances of false positives here. Now, let's talk in detail about how we do it, right? So we started working on this problem, I think, in December last year, during the time when LLMs were was a huge hype. So we also started with trying to leverage LLMs because LLMs were very good at code, understanding code as well as generating code, right? So I started with doing some experimentation by using an LLM. I remember it was, I think, Gemini, earlier versions of Gemini, to analyze known malicious code from some of the known malicious NPM packages. And I found that it was pretty good. It could identify most of the obviously malicious code blocks and as well as extract evidences from code blocks, which if you have to do without LLM would be a lot of work. You have to build your own parsers, you have to build your own syntax tree analyzers, and you have to build your own snippet extractors. So I thought that maybe LLMs are the thing, right? Because it will help you identify malicious packages. But then when we built our first system based on only on LLMs, and once we deployed it, we figured that it's just not possible to scale for all the packages published on open source registries with just by throwing code at LLM. And real life usage gave us this real life experience of LLM hallucinations. If you send a small code block to an LLM, it does a very good job. But if you send a very, very large, minified, obfuscated code block, it starts to show problems, right? The first version that we built, which was entirely based on LLMs, did not scale. At some point, it was producing a lot of false positives. It was not easy to combine our knowledge and opinion on what is malicious, what is not malicious as part of this analysis, right? Then the second version that we built was kind of flipped it a bit. We kind of added some functions, LLMs and function callings using, I think, if I remember correctly, LangChain SDK. It's what so-called agentic AI now, but back then MCP servers were not there, so I'm not sure we used to call it agentic back then or not. But yeah, it was similar. You would have an LLM perform reasoning and chalk out a plan of action and then call functions such as pulling a package from package registry, extracting it, enumerating the files inside it, analyzing them, and then finally making a decision. This was even worse than throwing code at LLMs because when I evaluated this with a bunch of known malicious package, every time it was producing different type of results. The plan used to look different for the exact same package when I was running it multiple times. And it was very hard to debug. Like it was hard to debug why the LLM generated a particular plan. Maybe there are ways I was not familiar with, but it turned out that this approach would also not work for the scale that we were looking for. Finally, we kind of resorted to doing the hard work of building a static code analysis engine. So that's what we did. We built a static code analysis engine using TreeSitter as the parser and a bunch of custom plugins that we built in order to analyze the syntax tree. The core code analysis framework is again open source and available for anyone to reuse. But we did use a bit of LLMs. I will talk more about it as in future slides. So the reason why we kind of chose the static code analysis route was compared to using only LLMs for code analysis, the static code analysis was much more faster and much more deterministic. I mean, in fact, it is 100% deterministic, right? We were not using anything non-deterministic as part of the static code analysis approach. We also needed to capture real evidence in code. So which is why we kind of leaned towards using static analysis approach instead of taking a dynamic or runtime analysis approach. Like many people ask me that, why are you doing this static analysis approach? It's hard. You have to do a lot of work. Why not just run open source packages and see if there is a malicious behavior? The reason why we decided against that is because we wanted to capture real evidence of malicious behavior in code and not just on runtime. Runtime has its own challenges with libraries. You just can't run a library. So that is a separate problem altogether. Also, with the static analysis approach, what we wanted is, also have a set of human knowledge about malicious code analysis or malicious code patterns captured somehow, and then use that to classify a block of code inside an open source package as malicious or not, right? For that, we still actually used LLM, the final last bit of classification. And we also wanted to, continuously improve this system. So it was much easier to, build plugins and improve these plugins on top of static code analysis or, conventional static code analysis than dealing with LLM-based applications. Finally, it kind of looks like this for us. So what we do is that as I said, we still use a bit of LLM for final inferencing, but we do have a very large set of filters that take care of all the package analysis before using any kind of LLM analysis. Specifically, whenever we are analyzing any package, say, let's say an NPM package, we would first fetch the package from NPM package registry, enumerate through all the files inside the NPM archive, use Yara rules. We use the Yara Forge project, which has a bunch of rules for known malicious patterns. So we use the Yara rules, and we already have this package insights information, like how popular a particular package is, what are the stars, how many forks are there, how many stars are there, what is the project inside, open source project associated with the package. Then we also built something interesting. We built what we internally called a code capability analyzer. Because if you remember, I said my initial experiment of throwing some known malicious code block to an LLM yielded good result. I don't want to throw an entire source file to LLM, but I want to throw a small block of code to an LLM and have it reason that is it malicious and classify it to the type of malicious behavior that particular code is doing. In our experience, LLMs are very good at that. So with the code capability analyzer, we performed conventional static code analysis of function blocks and basic blocks of code in order to identify if it performs some operation which are potentially risky in nature. When I say risky, it means it is performing, say, a network operation or a file system write operation or a process execution operation, right? So what we do is that we built some custom analysis on top of tree-seater parsed syntax tree. And what it does, it identifies the imports and function calls in the program and matches it with the language specific runtime. Say, for example, if you're using Python and if you have to, write a file, you would most probably import the OS package and call, say, os.open or os.write or something like that, right? Our static code analyzer for code capabilities, it would identify based on such imports and function calls inside those imports that this block of code is potentially performing a file system write operation, or this block of code is potentially performing a network operation, right? So all of this static code analysis, the Yara rules, package insights, project insight, all of this is done to filter out only those block of code which has very high likelihood of being malicious. And we send only that block of code to LLMs to confirm that if they're malicious and also identify the malicious behavior as well as do some metadata extraction like this MITRE attack framework ID and all these things, right? Finally, based on all the signals, so why multiple signals? Because say in a particular NPM package, you have a lot of source files, right? It's not just a single file. So we are analyzing every single source file or every single file inside an NPM archive or a Python package archive with this filters. And whatever files matches these filters, we are also analyzing those blocks of code with LLMs. So this way we are generating a bunch of signals that this is a signal for a potential malicious activity in this file inside this archive, right? Finally, we combine all these signals along with our past knowledge of what are some of the common malicious behavior we are seeing, what are the common false positives that we are seeing. We combine all of them in a prompt and use an LLM for the final inferencing. The last step is more about contextualization of the decision making. Because if you imagine, code is code, right? A behavior in a particular library can be malicious, and the same behavior in another library may not be malicious. Say, for example, if you see some code which connects to some random URL and performs some data transfer in a cryptographic library, you would probably be worried. You may consider that to be a malicious. But if the same behavior exists in, say, a SaaS SDK or an HTTP client library, you would not consider it to be malicious, right? Because it's required for meeting the intended purpose of that particular library or package. So that we can classify a behavior as malicious within the context or within the stated purpose of the particular package, we use a LLM in the final step with this stated purpose as the context and the set of signals that we have gathered from prior static code analysis and LLM-based analysis. So the last step is where we finally classify whether a given package is malicious or not. We also benchmark this detection system with Datadog's known malicious packages dataset, which has over 5,000 known malicious packages. I will not go into the details of this. If you're interested in this, you can read more about it in our blog. And by the way, we covered around 96.5% of that dataset. Okay, now we saw a lot of things that we do to detect malicious packages. Let's talk about how does the community benefit from it. Any data that we produce from the package analysis service, which is a cloud-hosted service for us, is available through APIs. So if you're a researcher, you can reach out to us and can, the API is available. We just have to find the right documentation for you so that you can get started. It is also integrated with VET, our free and open source software supply chain security tool, and you can use VET to protect against malicious packages as part of your CI/CD itself. Another thing that we do is whenever we detect any malicious package that we can confirm with manual analysis or through some other complementary analysis, we immediately report it to the package registry as well as to OSV. Recently, we have been credited with reporting multiple malicious packages in the OpenSSF malicious packages project and the OSV project. Okay, enough talk. Let's look into the demo. The malicious packages data is integrated with our free and open source project called VET. You can go to github.com, save VET, follow the instructions to get it installed. So I'll quickly show a demo as part of this thing. Let's do VET inspect. Yeah. So this is one of the malicious package which I read about. It's not like we detected it because it has been there for since 2022. We did not detect it, but retrospectively, when we analyzed it, we found it to be malicious. So you can just submit a package for analysis using VET like this. It will tell you whether it's malicious or not, and it will give you a URL for checking the details. So when you open the URL, you would get something like this, right? So here you can see all the details on why this is classified as malicious. You can also integrate VET as part of your CI/CD. For example, let's look at a real example only. In this particular pull request, we are intentionally adding a known malicious package. This particular one, again, which was detected and reported by us. If you have VET in as part of your CI using GitHub Actions, it would look something like this. It would see what all packages are being introduced as part of the CI. It will check what is malicious and block the same. Cool. That's about it. Thank you so much. Hope this talk was useful. If you are curious about malicious packages research, do get in touch with me. If you want to protect against malicious packages, do try out VET. It's free and open source. Thank you so much.
Hi everybody, the title of my talk is Security Chaos Engineering Avoiding Payments Ransomware Gangs. My goal is that by the end of this talk, you will have a solid understanding of why security chaos engineering is essential today and how you can start leveraging to build more resilient defenses against threats like ransomware. A little bit about me. I am Yuri Niño. I work as cloud application engineer in Google Cloud. My daily activities include providing recommendations and consultancy about SRE, disaster recovery testing, and good practices to migrate solutions to the cloud. Also, I am chaos engineering advocate, promoting the adoption of this discipline in my country. And this opportunity, I will discuss security chaos engineering and how to apply its principles to mitigate ransomware attacks. So, what we'll cover today? First, we will start with a brief introduction to ransomware. We will review the threat landscape and why it is critical concern for organizations today. Following that, I will dive into why we need security reliability. We will discuss the limitation of traditional security approaches and the importance of building resilient systems. Then I will introduce the concept of security chaos engineering. We will define what is it, how it differs from other security testing methods like penetration testing, and its core principles. The core of this talk will be how to use security chaos engineering to anticipate ransomware attacks. We will explore practical ways to apply chaos engineering principles to proactively identify weakness, test our response and recovery capabilities, and provide reliability to our digital solutions. Finally, I will wrap up with the key takeaways from the session. But before that, let's look at a real world example of devastating cyber attack. This slide highlights the NoPetya attack from 2017, often refers to as one of the most destructive cyber attacks in history. You can see here the kind of message organizations received with a notification that critical systems were encrypted. But NoPetya wasn't about demanding payment. It was designed for destruction, whipping data and crippling systems globally. One of the most impacted companies was Maersk, the world's largest container shipping company at the time. In that case, NoPetya blocked Maersk's website and IT systems. It wasn't just an IT problem, it had massive physical and financial consequences for Maersk. Maersk estimated that the cost ran into the hundreds of millions of dollars. NoPetya attack is a reminder that cyber threats are not theoretical. They impact our business, the reputation of our business. Let's consider a personal angle for a moment. Ask yourself the question, what would you be willing to do to recover a file on which your reputation depends? Think about that for a second. I asked the same question to some colleagues. The results show that 76% of respondents said yes, they will be willing to do something significant to recover such data, and only 24 said no. The previous results are interesting because, according to Comware, a ransomware remediation firm, the number of victims choosing to pay has fallen to a record low. In contrast to, at the start of 2019, 85% of victims paid a ransom. By the middle of 2020, first person has fallen to 46%. And in 2023, only 29% of victims paid the ransom. As a conclusion, for many victims, the main reason for paying the ransomware was to prevent a data leak, rather than to obtain the keys to decrypt files. This sketch gives us a visual overview of some common types of malware. This is a beautiful illustration about that. Probably you may recognize here terms like spyware, viruses, trojans, or phishing. The idea behind ransomware is to take your data or systems, lock them, encrypting files and blocking access, and then send you a demand. Give me the money or you get your access back. ABM reported in 2023 that ransomware was responsible for 17% of the cyber attacks. Understanding this is crucial because it directly frames the problem we are trying to solve. Precisely, the goal with security chaos engineering is to build the confidence and capability to resist that pressure by ensuring that we have an alternative to mitigate these incidents. Review now how ransomware attacks occur. They commonly start infecting a system through several methods, including phishing emails, malicious websites, exploring vulnerabilities, and malvertising. Once inside a system, ransomware can operate in a couple of ways. Encrypting ransomware, in this case, it encrypts files on the victim's computer or network, making them inaccessible without a decryption key. Local ransomware is another type, occurs when the victim's entire computer system is locked, often displaying a full screen demand. After the files are encrypted and the system is locked, the ransomware displays a note that includes explanation that the data has been encrypted or the system locked, instructions on how to pay the ransom, typically is cryptocurrency, for example. Finally, it is important to mention that ransomware has been evolved to double extortions and remands of the malware. Data from Blackbox, another security firm, showed that 244 ransomware hacks were confirmed, an increase of 25% compared to the same period, being government the most affected person with 47% attacks. Other infected sectors include healthcare, education, technology, services, retail, for example. According to the firm, the cost connected to the hacks stood at $7.5 million to 2019 alone. It is a conclusion for this first part. Critical gaps are often in preventing the initial breach and in the confidence and capability to recover without paying the ransom. We strive to prevent breaches, investing in lawyers in security defenses, and that prevention is absolutely necessary. However, the reality is that sophisticated attackers can sometimes find a way through. While traditional security often focuses on preventing known threats, it is not enough for complex dynamic systems and novel attack methods. Traditional security practices work well with known vulnerabilities and established attack patterns. Think about signature-based antivirus, patching node flows, building strong perimeters, and responding to alerts based on the predefined rules. But at this environment, simply focusing on preventing node threats and building a static defense perimeter is not enough. That is the conclusion here. Our current methods in traditional testing are not enough to mitigate sophisticated attacks in the state of the art in our market, industry, and academy. Probably you are familiar with chaos engineering, intentionally injecting failures into systems to build resilience. Security chaos engineering applies similar principles but with a security focus. Let's look at two definitions. First one, security chaos engineering is a socio-technical transformation that drives the organization through the ability to respond to failure and adapt to evolving conditions with speed and grace. That is very important, with speed and grace. And the second definition in the literature is security chaos engineering is the identification of security control failures through proactive experimentation to build confidence in the system's ability to defend against malicious conditions in production. And that is important. It is important mention that it is not necessary in production. That is a definition for that, but you can experiment in low environments, and since you provide ability to prevent this type of incidents, you are giving value for your organization. And now, how do we use security chaos engineering to prepare for ransomware and avoid payments? These are the steps. Hypothesize. We start by identifying our assumptions about the ransomware defenses and the recovery capabilities. Simulate. That is the second step. This is where we run safe and control experiments. Using chaos tools or frameworks, we simulate ransomware-like behaviors. The key word here is safe. These experiments, which must be carefully designed and executed to avoid causing real harm. 3. Observe during and after the simulation. That is very important. Before, during, and after the simulation. We observe and measure. That is important also. Provide metrics about that. We gather data on detection, alerting, and the quality and speed of our response. 4. Improve. This step is about taking action, patching new discovered vulnerabilities, for example, adjusting security control configurations, enhancing our detection roles, improving our response playbooks, and most importantly, fixing any issues with our backups and restore procedures. Finally, repeat, security chaos engineering is not one off project. The threat landscapes evolve, so our system change. People join or leave teams, for example. This process needs to be ongoing. We repeat the cycle, identifying new assumptions, running more simulations, observing the results, and continuously providing improvements about this process. The continuous loop is what builds lasting resilience and ensures that our confidence in our recovery capabilities remains high. Start by forming hypotheses, like as I mentioned, this is a detail about the steps. For the first step, define hypotheses about security controls. Start by forming hypotheses like, if ransomware encrypts file on an endpoint, the experiment should detect and isolate the machine. Backups should remain untouched, and if ransomware it hits production systems, then test the assumptions under controlled conditions. The second step is to simulate ransomware behaviors. Use controlled chaos experiments that mimic ransomware activities. For example, file encryption simulation using Benning scripts to mimic encryption patterns. Mass file access modification, simulating rapid file change to test detection and response. Process injection, attempt to mimic malware behavior and test EDR response. Tools like Atomic Red Team, that is a great tool. Caldera and Infection Monkey, the classical Infection Monkeys, based on the first idea provided by Netflix, it could be useful here. Next, test detection and response mechanisms using SIM, IM, EDR, IDS, and APS alerts. Automated simulation, isolation of endpoints, backup integrity checks, or incident response time. And a fourth step, improve based on findings. Harden EDR roles, limit permissions, for example, deny write access to backup drives, improve segmentation to contain ransomware spread, and finally train incident responder using the test results. That is very important because these exercises are related to humans, so it's very important to provide trainings and workshops, for example, master classes related to the topic. Finally, automate and retest continuously. Like chaos engineering in reliability, security experiments should be continuous. Integrate into CI/CD pipelines or periodic testing routines, and evolve attack simulations as ransomware tactics evolve. proactive validation and recovery is paramount. They are final takeaways. So these 5 conclusions you can take away for you. First one, proactive validations of recovery is paramount because security chaos engineering shifts the focus from preventing breaches to actively and continuous validating your organization's ability to recover from disruptive events. Build muscle memory and confidence and incident response by simulating elements of a ransomware attack and recovery scenarios. Draw chaos experiments and game days. Game days are very, very funny and important here since they provide spaces for testing in a dynamic way. Teams build with this exercise. Teams build crucial experiences, identify communication gaps, and gain confidence in their ability to respond effectively, reducing the likelihood of panicking and resorting to payment. Uncover blind spots in security controls and monitoring, and finally reduce financial and reputational risk by providing resilience. So that is all. Thank you so much for being here. How to begin with chaos engineering and specifically with security chaos engineering? There is a Slack channel in which you can interact with another persons about this topic. Try to involve to meetups or this type of conference in which you have the opportunity to interact with experts about this topic. And the most important, consult InfoQ. That is a good reference. For example, in the last week, they published a conference from Kennedy Tortuga, who explained what is a security chaos engineering. And finally, that they are my social networks. You can find me in Twitter, in X, Medium, and LinkedIn as Judy. So thank you so much for being here. Thank you so much for your time, and I hope that this content could be useful.
So we had 2 topics there. I think that everybody probably understands why I brought in the SafeDep and and their open source project VET. We've talked a little bit about maybe doing some integration work together, and I hope that that's something we can do in the future because we have a lot of similarities, and I think that we could join up and do some interesting work around that. Chaos engineering, though, how do we apply? I mean, she gave us a good example of how to apply chaos engineering to ransom attacks. That you'd think would be really, really hard to do. How do you get the system back up and running as quickly as possible? And as we start talking about auto remediation, it's just about when it comes to software vulnerabilities, can we just figure out how to fix it fast? That's sort of the basics around chaos engineering. So both of those 2, I hope that you can take some lessons learned and the idea of speed and grace and responding to these issues. I think we should apply to everything that we do. Did anybody have any comments about either one of those sessions? The SafeDep folks, I hope that we see them in some architecture meetings in the future. And do reach out to Abhishek. He's pretty easy to get in touch with. And he's always happy to talk about what they're doing with VET. I will take that as we are ready to go to our last one. That's okay. Let's go ahead and move on, and we'll go right to a closing after that. So everybody, thank you very much, and we'll see you on the other side.
Hello, my name is Danny Nebenzel. I'm the CTO and co-founder of Scribe Security. Scribe Security provides a software supply chain solution that revolves around the idea that software is not to be trusted unless it can prove its trustworthiness. such a proof is done using evidence and rules, like in court. One of the evidence types we support is S-bombs, and when we say S-bombs, of course, we mean much more than the minimal NTIA requirements. Everything you're going to see here can be achieved by our platform. So let's delve in. So what will we have here today? Setting up the story, motivation, and going through a set of use cases of utilizing S-bombs, and wrapping up. Once upon a time, it was right after the chaos of Sunburst and Log4j, and I was appointed S-bomb lead at imaginary.com. It was a great ride. I had a huge S-bomb collection, but I could feel the wind of change coming. The great again times were just around the corner, and I started seeing headlines in the news like CISA budget cuts and my boss talking about deregulation. That is when my job security instincts kicked in. I realized that it was time to prove the value of S-bombs to my boss and through him to headquarters. I did my research, and after a few minutes, I came out with my action plan. I understood that my client here is my boss, my product is my S-bomb collection, and I need to show him the value. What does he care about? So efficiency and prioritization. Our security team is overwhelmed with CVEs and other findings, and these things also reoccur across products. So it's a lot of work to do, and being able to decide what to do first and doing things more efficiently is for sure a high priority for him. He's responsible for our regulatory compliance, so helping him to assure that we are compliant is critical. I did not forget the S in CISO security, all about reducing risks. And knowing how things work in the real world, communication with developers is crucial. Just throwing vulnerabilities on the dev teams does not bring us far enough. We need to communicate with them effectively. So I decided to bombard my boss with 4 reports reflecting these values. Let's go to the first report. Report number 1 about efficiency and prioritization. This report has 2 parts. It's a briefing for 2 meetings that are planned in our calendar: the Skyrocket 1.4 release security review and our monthly CVE management review. Skyrocket release. So when we think about my Skyrocket release brief, this time was very short. We have resolved such and such vulnerabilities, and a new vulnerability has popped up. That's it. Okay, so leaping out of this report, going back to our lecture, what we have here behind the scene is S-bomb diff. Let's look at the differences between S-bombs. Since it's a release meeting, we assume that basically everything for the previous release was already addressed, and we need to address only what has changed. So this is like a simple analytic you can do with S-bombs. Just look at the differences between versions. Second part of my report was for the CVE monthly meeting. CVE 2027-0001 impacts 10 of our products, and it can be mitigated via a web application firewall that fully resolves 10 critical exposures. Now that's efficiency. Instead of going to 10 dev teams and trying to make them handle these vulnerabilities, we can delay this fixing and still be secure. All our vulnerabilities data shows that we have a few KEV vulnerabilities, and KEV is a big no-no. If CISA already published that this vulnerability is being exploited, we cannot have this such CVEs in our product. Again, leaping out of this report, once we have a huge collection of SBOMs and we put them in our inventory with BI capabilities, we can start asking questions that help us in prioritization and efficiency. For example, we can ask to see the CVEs that are common to many products, and in some cases, we can handle these vulnerabilities in one shot, like in this example. Or we can ask to get all the products that have any KEV vulnerability or any suspected to be exploited soon vulnerability by taking EPSS data. And again, this is a way to prioritize given a large set of SBOM representing many products, given publicly available intelligence, such as the EPSS data, which is published daily, and KEV data, which is published regularly. In order to perform such analysis efficiently, one should also collect, in addition to the SBOMs, context information. Okay, so if I know that a product is publicly exposed, has an interface to the internet, then I would pay more attention to vulnerabilities that have an attack vector from network. And these are exactly the vulnerabilities that may be solved by a web application firewall. So for this example, having the characteristics of this payload and the characteristics of the vulnerability as part of the context information of the SBOM can help me make better, more efficient decisions. Let's move to my second report, regulatory compliance. So when considering regulatory compliance SBOM, the first thing that comes to mind is licensing. That's a typical data item which exists in most SBOMs. So this is my report. I detected use of the JSON license in our products, and JSON license, well, people like it very much because it essentially says the software should be used for good and not for evil, but lawyers don't like it so much. I see we have a GPL component in Skyrocket Personal Edition, and Personal Edition is something that we distribute. So a copyleft license is could bring us to be not compliant. Let's stop here for a minute. Okay, so simply having license information can help, of course, in pointing to regulatory issues. Again, here we need the context. Just saying that we have GPL components and a lot of payloads running in our cluster is not interesting. What is interesting is to point that we have a GPL component in components that we distribute, and thus may be violating the licensing requirements. Let's go back to my report. So we have SAMGRIPT rule license update. As you may all know, SAMGRIPT is one of the best, if not the best, static analysis open source solution, but they have updated their license last year, and license has changed, and we need to address this this change. Leaping out of my report, again, here comes in the SBOM diff capabilities. So using the diff, we can detect that something has changed and something calls our attention. A note here that it's not always that simple. For example, SemGrep rules are something that you would not install as a developer. You would install the SemGrep software. So the SemGrep software pulls the rules first time you run the tool, and it could easily go undetected. If, for example, you have SBOMs from production, probably after the SemGrep tool has already been run, the rules package could be detected. Okay, so package detection and its accuracy could be tricky. In this case, very tricky. The second part of my compliance report was the nice surprise from my boss. FedRAMP container security compliance. Well, complying to FedRAMP is a big thing because it enables us to sell to the feds. But leveraging our SBOMs, we have streamlined the compliance to key FedRAMP container security requirements. So the FedRAMP standards have a set of requirements regarding container security, and these include like 6 requirements. Of them are verifying CI build. So using our SBOMs, I can tell exactly where each payload has been built and that it has been built by a build pipeline and which build pipeline. The FedRAMP requirements require that the all images are rescanned once in 30 days. So instead of scanning the images, I just scan all SBOMs of images that are in production and make sure that I have a updated scan. Security configurations. Well, taking information from the SBOM, I can evaluate some of the security configuration best practices. And inventory management. Okay, that I was compliant by default just by having my SBOM inventory. Leaping out of this report, so there are 2 things I want to emphasize. One is verifying CI build. Okay, so the CI build is part of the context of the SBOM. Okay, so SBOM is like a snapshot or X-ray shot, of the software. It says what's inside. But if you don't know the date and the time and who's the person that it's his X-rays, that it does not have much use. So the context, as we saw previously, could include where it is deployed. It could also include where it has been built. This can be part of the SBOM. It could be external to the SBOM. In Scribe, it's external to the SBOM, and it is a way for us to search and retrieve SBOM. So we retrieve by context, but you can do your own decisions here. Okay, so having the CI information as part of context enables, or as SBOM enables showing that this payload was not built on some random developer machine, but it was produced into the software factory. Similarly, security configurations. So we believe that when you do software component analysis to a Docker image, the first thing you see in an image that it is made of layers, and layers have their own information. For example, the command that was used to build this layer. And we collect this data as part of our SBOMs, and we recommend doing so. And once you do so, you can assure that some of the best practices of container security are implemented. For example, assuring updating all packages as part of the build, or assuring use of non-root user when executing the container. So now to my third report, security risks. Okay, so again, the default use of SBOMs is to point to bad packages. Again, having my SBOM inventory, I saw in Hacker News that the TJ actions changed files malicious action has been published, and many pipelines are being attacked by using these actions. And I could easily search through our whole inventory and point exactly to which teams are using these actions. We could also, using our SBOMs, point to users modifying sensitive files. Like in our company, only DevOps and DevSecOps are supposed to change the CI files. We could detect who else is touching these CI files. We had a poor experience with one of our build machines being compromised. But using our SBOMs, I could point to which payloads have been built around the time of the attack on this build machine. So clearing these builds or rebuilding them could be done easily, and we did not need to go around and rebuild everything that our software factory built. And remember, the SolarWinds attack using SBOMs that include integrity information can be used to verify integrity of whatever. So it could be integrity of files or integrity of whole images. Leaping out of this report, in order to have the TJ actions compare file as a component, one needs to have SBOMs taken in different places along his software factory. So we do not expect the final image, SBOM of an image, to include much build information, but we do expect an SBOM of the sources to include GitHub actions. And if you would run sift on a directory of your project, and you have your .github workflows over there, then the GitHub actions would be mapped as components in your SBOMs. Okay, so again, SBOM is not only final packages, taking SBOMs along the pipeline has values. Taking SBOM of the sources can have other upsides. For example, if we collect also committer information, for example, who committed, who was the last committer who committed this file, and some information about this commit, it can be also useful. And so we support it in our tools. And once you collect such data, you can go ahead and have policies about who's touching which files. Blast radius. So if we discussed the importance of context. So one of the pieces of context should be information about the build machine. Some of this data can also be incorporated as part of the SBOM. And using this information, we can know what was built where and use this information. Communicating with developers. This was my last report, and I had to make sure that it is impressive. So here's the graphs came in. The first use of SBOMs for helping us with communication with developers is just enabling us, the AppSec guys, having the information. So we don't only have CVEs, we have package informations, we have the pearls. We can go to osv.dev and get more information. We know about the builder and the build machine and the build number, so we come educated to the developers. But we can do much more. For example, we can take we can analyze our data and start to understand trends and some typicalities about our product. In this case, we take a product. This is an imaginary product. The truth is it is a version of Elasticsearch. And we take the Docker image and we run it through a time machine. Each bar here in this bar graph represents the vulnerability distribution at a specific date. The purple line shows us the date of the release of the product, and we can learn here a lot. So first, we see that it behaves quite linearly, and once we analyze a few types of products, we can understand that the slope may be different between technologies and products, and this can help us make the managing of vulnerabilities much more predictable, okay? Because we know more or less what would be the number of new vulnerabilities that are expected to pop in the next month. We can get ready for that. We could also set the enough is enough bar, and we can show the developers this graph and explain to them, you see your software that you're developing, it's like cheese. When you leave it out of the refrigerator, it gets spoiled, and we all understand that you need to buy new cheese once in a while. So take into account that you need to invest in refreshing your images once in a while if you don't want vulnerabilities to get out of control. Another type of report is comparing versions and comparing products. So use case here is evaluating the team performance or evaluating product performance on procurement. Here we see two sets of versions of the same product, but it could be like two products. And we can clearly see the difference between the two teams here, right? The left side team does not work on vulnerabilities until it's forced to, and then it crashes in and fixes a lot of stuff. And the other one keeps a low level of vulnerabilities a long time. So when buying a product of type A or type B, you could choose what's better, what represents a better security culture of the company, or if it's internal to the company, what represents better behavior of the dev team. Looking at the differences and between versions and the time that elapsed between versions and availability is handled, we can calculate both mean time to repair and CVE time to repair. So the MTTR represents the overall team performance, and the CVE can represent the team responsiveness, how fast they manage to respond to new and probably critical vulnerabilities. Again, communicating with developers using such data moves the discussion from blame to data-driven decisions. So after bombarding my boss with all these reports, I was relaxed and relieved. I sat down on the couch near the coffee corner and enjoyed my coffee and slowly drifted away when I heard my boss talking to some mysterious headquarter guy who was asking, but what about the AI bombs and the ML bombs? So what did we have here? We saw a few set of values that can be achieved using SBOMs to help us be more efficient, prioritize, assure compliance, solve many security cases, and communicate better with developers. To achieve this, we need rich SBOMs with much more than the minimal information that is required. And we need context. Where was this picture taken? Where, by whom, by which machine, which build run, etc. when we take all these SBOMs and throw them into a SBOM lake with BI infrastructure, we can go ahead and extract value from the huge SBOM collection using a few techniques, either simply querying the SBOM lake, or using SBOM diffs, or SBOM time series, or version series, or derivatives and slopes. And I hope this gives you some ideas that you can implement on your SBOMs collections. So thank you very much.
Thank you for attending SecureChainCon 2025. And thank you to everybody who submitted talks. They were great, and we appreciate your willingness to share your knowledge and take the time to submit a video for SecureChainCon. We'll do this again in December, where we do a smaller version of it, but no less informational. So look forward to our December event when we also do beer and donuts and celebrate everybody who's contributed throughout the year. And if you're interested in contributing, we do have some interesting projects that we're working on. The Ortelius team have started working on AI and learning about model context protocols. So if you're interested in doing that, please join us. Just go to ortelius.io and you'll find all the ways you can start becoming a contributor. Thank you for now, and we hope to see you.